Welcome to the mini test solutions, and let's get started so I don't steal as much time as I did in the last one. Simplifying expressions. First, we target the first part and then the second part. I will color code the first and the second part separately, multiply each of the terms with the factor in front of it. Same for the second bracket. We get them all in the solution. Now we change the colors to see when they have a common factor, so if they have a common factor of x, or they're just numericals. I mark them separately so I can add them together, this giving us 10, this giving us plus 3. Result being 10x plus 3. Next up we have x times y, and they're both to a certain power, and they're multiplied, of course. So I basically color-coded them, multiplied them together, and added the levels as we did mention at the start of the video, which gives us x to the power of 7 and y to the power of 7, which can also be rewritten as xy all to the power of 7. Either of these two works. I prefer this one, it's a bit more visible, easier to calculate. Next one, 2x squared minus 8 divided by 4x. So first off, we can factor out 2, and then cancel the 2 in both parts of the fraction. So we get 2x in the bottom and x squared minus 4 on top, which is the solution itself. I wish there was more to do, but it's a pretty simple exercise, nothing much to do. Now, expanding the brackets, we get the same approach as we did before. Multiply the x with negative 7, 3 with x, and 3 with negative 7. We color code how we multiply them. We get it like so. Make these two into a square, add these two together into one term, and copy over 21, minus 21 of course. And we get x squared minus 4x minus 21. We have 2a minus 5 all together squared. That one's not hard. We square the first part, we get 4a squared. We square the last part, we get 25. The center is minus 2ab, which is 2 times 5 is 10. 2 times 10 is 20, so minus 20a in the center. This is the solution. Now we have y minus 2 all together cubed. We write it together as y minus 2 and y minus 2 squared. We open the second bracket. We do the same thing as we did in the video. We multiply each of the terms with each of the terms, add them together, or just use the rule for 3a squared b and 3ab squared, and this is our final solution. Factoring expressions. Well, we see that there is a common factor of 3x, so we take that out, and what's left is 2x plus 3. After that, we have x squared minus 4x minus 12. What numbers divide 12? And what numbers, when added together, give us minus 4? We see that if we use this mirror rule, we see that minus 6 and plus 2. Also, this is a shorter and faster way of solving that problem I said before. So you find this by the mirror rule. These two can be multiplied, giving us 12 or minus 12, where one of them is negative. And these two, when added together, give us minus 4, meaning that the solution, as we color it here, is x minus 6 and x plus 2. Simple, easy enough. 25 times y squared minus 9. We use this formula, fill in the roots of each of the terms. We get this. Not much to talk about. Hopefully, we know that this one is missing something, that it's definitely not this one, and it leaves us the answer with this one. Because if we break it apart, we get a squared minus ab plus b squared. Rewrite x squared plus 6x plus 9 using one of those special formulas we learned today. Which one? That's completely up to you as long as you get it right. First, we have to determine which one to use. Well, we see that 9 is a square of 3, and that 6 is 3 plus 3, which gives us the square of the sum. Not very complicated, not very hard. Next up, which of these expressions can be factored only using the difference of squares, getting non-fraction / non-decimal results? Let's go step by step and solve each of them. The first one, we take out 2, and we have x squared minus 8. The problem here is that we factored out something, so this is not only the difference of squares, and also that 8 is not a square. 4 is, 16 is, 8 isn't. So this example is not correct. Next up is x plus 9, or x squared plus 9, which has a non-real solution, which absolutely is not a difference of squares. Last one, this one is a difference of squares because it follows the formula, and we get the result of 2x minus 7 times 2x plus 7, meaning that the third example is right. Now for the challenge to truly push you to your limits for today. Multiple concepts used in one equation or expression. 2x cubed minus 18x. We factor out 2x. We get x squared minus 9. And we see that's a difference of squares, which gives us x minus 3, x plus 3, which is the final result. For b, we have x minus 1 times x plus 2 times x minus 3. You can solve this any way you want. You can multiply first to first, first and last to first. I decided to do the last two first because they have bigger numbers, and multiplying with 1 is just easier. So I'll multiply them first. I carry over x minus 1 and multiply the 2, giving me x squared minus x minus 6. And if I multiply x with each of the following terms, we get x cubed minus x squared minus 6x. And on top we add minus x cubed plus x plus 6. As you see, minus 1 when multiplied with plus gives minus, when multiplied with minus gives plus, and when another minus, it gives plus. You could put minus in here, between the brackets, but then you would just have to copy these signs exactly as they are, because you already used this negative sign here. And it will influence what these signs are. But in this case, this minus stays minus, this plus stays plus, this plus stays plus, which gives us all of this. Now we common the same factors or terms. We get 2 minus x squares, so we can carry that over, and minus 6x plus x is minus 5x, which is the final result. Thank you so much for solving the test. Hopefully everything went good. You succeeded in solving the test with high accuracy. And yes, if you have any more questions, please comment down below. I will gladly help. And see you on in the next video. Bye!